Okay, so today we have 2.2. We're going to be looking at piecewise functions. So the definition of a piecewise function is a function made of different output formulas with different pieces or parts of the domain. So you're going to have multiple functions with multiple restrictions. So our first piecewise function that we're given is this one, for example, 1. And how to read the piecewise function is important. So we have f of x equals x plus 1, and the only way we can use x plus 1 is if the x values we're given are less than -2. So that's the only way we can use x plus 1. So if we're given a value less than -2, that means we can plug it into x plus 1. Okay. And then it says f of x equals 5 if our x values are between -2 and 3 included. So if we're given a value from -2 to 3, the output or the function we're going to use is just 5. And then if f of x equals x squared, then this only works if our values of x are greater than 3. So if values of x are greater, we're going to plug it in to x squared. Okay, so let's go ahead and try to evaluate this piecewise function. And here we're given, or we'll start with f of -5. So I'll call this number 1. F of -5. And remember, that -5 is the x value given. So if x is -5, which function do we get to use? The first, second, or third function?
The first.
Well, is -5 less than -2?
Yes, sir.
Oh, maybe I can't hear anybody. There we go. Sorry, say it again.
The first one.
The first one, good. Sorry, I always hit this little thing on the top where I can't hear anybody. So that means we get to use x plus 1. So that means that you'll get -5 plus 1, and then we'll get -4. Okay. All right, then let's try it again. Number 2. F of -3. So again, when x is -3, it is x less than, is -3 less than -2? And that answer would be yes, which means we get to use the first function again. So you would have -3 plus 1, and we would get -2. And then for the third one, we get f of 0. Okay, so now x is 0, and we have to look at which restriction this follows. So we know that 0 is definitely not less than -2, but is 0 in between -2 and 3?
Yes, sir.
Then our answer would just be 5. Okay. And then 4. F of 3. Well, we look, and here we're given x is 3. So this restriction says that x can be less than or equal to 3. So this means that our output again is going to be what number?
5.
5. There we go. Okay. And then what do we have? Oh, we have two more. Okay. And then we have number 5. We're going to say f of 4. Well, 4 is definitely not less than -2. 4 is not between 2 and 3, -2 and 3. And we know that 4 is definitely bigger than 3, which means we get to use x squared. So we plug 4 in and we'll get 16. All right. And then the last one, 6, f of 10. We know that 10 is definitely bigger than 3. So we get to use x squared again, and we'll get 10 squared, which gives me 100. So that's how you read a piecewise function. If you're given an x value, you go ahead and plug it, find out what restriction it belongs to, and then that'll tell you what function you're able to plug in on the actual piecewise function. So any questions on that one?
No, sir.
Okay. All right. Let's try it again then. Example 2. Go ahead and evaluate this piecewise function for the given x values. So number 1, we'll say g of -4, and is -4 less than 1 or greater than 1?
Less than.
It's definitely less than. So we get to plug it into the function x plus 4. So you'll get -4 plus 4, which will give us 0. All right. And then 2, g of 0. Well, 0 is definitely less than or equal to less than or equal to 1. So again, we get to use x plus 4. So you get 0 plus 4, and we will get 4. Oops. All right. And then 3, g of 1. Well, this restriction says that we can be less than or equal to 1, which means that, again, we get to use x plus 4. So you'd have 1 plus 4, and we would get 5. Okay. And then last one, 4, g of 3. And we know that 3 is definitely not less than 1. We know that 3 is greater than 1. So we're going to plug it into the second function in our piecewise. So you'll get 8 minus 3, and we'll get 5. Okay. So once again, that is how you evaluate and read a piecewise function. Given an x value, see what restriction it falls under, and whatever restriction it falls under, that'll tell you what function that you can use. All right, all good?
Yes, sir.
Yeah. Let's keep going then. All right, so next thing we're going to do is graph the piecewise functions. So for number 1, we have g of x equals 1/3 x plus 3, and we can only graph this for values of x less than 3. And then the next piece is -x for all x values greater than or equal to 3. So what we're going to do here, in order to graph the piecewise functions, is we're going to make separate x-y charts for both of them. So for the first one, I'll just put it in blue. I'm going to say x and y equals 1/3 x plus 3. And right above it, I'm going to put the restriction. So it reminds us of what x values we can only pick. So we can only use this function if we choose x values less than 3. Okay, so this restriction is telling us what numbers to pick. It says start at 3 and choose numbers less than 3. So when you plug it in for x into this function, you're going to want to be careful because here you have a fraction, and we definitely don't want to graph fractions. So the best way to get rid of the fraction is to plug in numbers that'll get rid of this denominator of 3, which means in order to get rid of that fraction, we're going to plug in multiples of 3 that are less than 3. So when I say that, well, we're going to start at 3, and then we're going to go less than. Another multiple of 3 that is less than 3 is going to be 0. And then another multiple of 3 that is less than 3 is -3, -6, and -9. We can keep going, but I believe that's all that will fit on my XY chart. Okay, and if you need help plugging these in, well, we can always use Desmos.
Professor, how is 0 a multiple?
Because, well, if you thought about multiples of 3, right? You will always do, you can say -1 times 3, 0 times 3, 1 times 3, 2 times 3. So when I'm saying multiples, I'm guessing like a multiplication chart. So 0 would be considered a multiple of 3. That make sense?
Honestly, no. I mean, wouldn't 0 times 3 be 0?
That's it. And that means it's a multiple of 3.
Huh. All right.
Because also, if you did multiply these out, I'd have -3, 0, 3, and 6. And what is the difference between each of these values?
3.
Therefore, 0 is a.
Oh, okay. I see.
Now you get why I'd say multiple of 3.
I wasn't thinking about it in terms of graphing.
There you go. Okay. So I'm just going to graph our XY chart using, or complete our XY chart using Desmos. And I'm going to type in the function just like I see it. I'll just do 1/3 x plus 3. And then I'll use that little table feature and type in the numbers that I've written. 3, 0, -3, -6, -9. And there we go. That'll help me fill out the rest of this chart. So at 3, I get 4, 0, I get 3, 2, 1, 0. There we go. Okay, but let's go ahead and look at our restriction. Our restriction says that x has to be less than 3. So can x actually be equal to 3 here? Does this say that x can be equal to 3?
Yes.
That restriction says only we can be what? Less than, right?
Yes, sir.
So since it says we can only be less than and not equal to, this means that this point 3, 4 is going to be considered undefined. Only because of that restriction. Because it says we have to be less than and we cannot be equal to it. Okay. So with that being said, let's go ahead and come back here and graph it. Oops. All right. So now when I graph the blue function and I start at 3, 4, an undefined point at 3, 4 is going to be an open circle. So any type of undefined point will always be an open circle. And then the rest will be closed. So next I'll be at 0, 3, -3 and 2, -6 and 1, and -9 and 0. And here is what the first part of our piecewise function looks like. Okay, now let's graph the next piece of our piecewise function. which is the function negative x. And I could do that in green, why not? So I'll make another XY chart. I'll say x and y equals negative x. And I'll put the restriction right above it, because remember, the restriction tells you what numbers to pick. So in order to use negative x, we have to choose x values that are greater than or equal to 3. So once again, this time we're starting at 3 and we're going greater than 3. Now, this one, we don't have to pick multiples of anything because there's no fraction to deal with. All we're doing is plugging these numbers in for x. So when I say greater than 3, let's just go 4, 5, 6, 7. Okay. And now we don't need Desmos to fill out this chart because all you're doing is taking these x values and making them negative. You're going to plug them into x and multiply them by -1. So this means that you'll get -3, -4, -5, -6, -7. And this time for this XY chart, we can actually use 3 because what does this inequality say? We can be greater than or
Equal to.
So this means that this point will be defined. So when I graph it at 3, -3, you're going to have 1, 2, 3, 1, 2, 3. I'll have a closed circle, and then everything else will be closed. And the rest of our piecewise function will go down and to the right. Okay. And that's how you graph a piecewise function. You'll make separate XY charts and just follow your restrictions. And of course, what's cool about Desmos is that it can actually help you using the restriction, so you can check your work here. So we're going to get the same graph, although Desmos will look prettier. Oops. And let me go ahead and close this, and I'll type it in again. 1/3 x, and it's 1/3 x plus 3. And then next to it, I'm going to type the restriction in. It's going to use a fancy brace, and I'm going to say, oops, x less than 3. And close your fancy brace. There you go. And then for the next one, I'm going to have negative x, and then put my restriction, x greater than or equal to 3. And let's look at the graph. This is exactly what our graph looks like, but with more numbers, of course. So if I zoomed in to what we have here, our graph only goes to 10 and -10. If I go ahead and put my finger on this line and I drag it up, you will see that as I get to that 0.34, it's going to say undefined, just as I stated in our XY chart to the right. Pretty cool, huh? So, and it's all based on the restriction. For the blue line, if I go to that 3, -3, it's going to be a complete circle. It's going to be a closed circle, a defined point. And that's why it states 3, -3. All good?
Yes, sir.
Yeah. Desmos for the win. All right. Let's do it again. Number 2. Graph the next piecewise function, g of x equals x plus 1. We can only use that if our values are less than or equal to -3. G of x equals -1 if our values are between -3 and 4. And g of x equals 1/2 if our values are greater than or equal to 4. So once again, just go ahead and make that XY chart for all 3. So x and y equals x plus 1. And right above it, I'll put the restriction. So in order to use x plus 1, we have to choose values of x less than or equal to -3. And again, the restriction tells you where to start. We start at -3 and we go less than. -3, -4, -5, -6, all stop at -7. And then take all these x values and plug them in to the function x plus 1. So all we're going to do is add 1 to all these x values to get my y value. So -3 plus 1, -2, -3, -4, -5, -6. And let's go ahead and plot that first. So here I'm at -3, -2, and then -4, -3. And then we're just going to keep going down to the left. All right, there's the first part of our piecewise function. Now, let's make an XY chart for the second one. It's going to be g of x just equals -1. So for this XY chart, you're going to have x and y equals -1. And we can only use this function output if my x values are between -3 and 4. So it's telling us again what x values to use. So you'll get -3, and we're going to go from -3 to 4. So -3, -2, -1, 0, 1, 2, 3, 4. And no matter what these x values are, guess what the output's always going to be?
-1.
That's it. -1, -1, -1, -1, -1, -1, -1. But based on our inequalities, can I actually use 3 and 4? -3 and 4. Does it say less than or equal to, or do they just say less than?
Less than.
Less than. So this point will be undefined, and this point will be undefined. So when we graph the next one at -3, -1, I'll have an open circle. And then we'll go to the right, 0, 1, 2, 3, 4, we'll have another open circle. All right, there's the second one. And now we graph the last one. So we're going to graph 1/2 x. So we'll make an XY chart for that one. So x and y equals 1/2 x. And we can only use this function if my x values are greater than or equal to 4. Which means, again, it tells us where to start. We'll start at 4. And of course, since it's a fraction, we don't want to graph a fraction. So we're going to choose multiples of 2 that are greater than 4. So we would go 4, and then what would be the next number?
3.
Greater than 4, and a multiple of 2.
6.
6. Good. 4, 6, 8, 10. And you'll plug these into 1/2 x, and the result is going to be half of all these numbers. So 2, 3, 4, 5. Okay. And since this said greater than or equal to, we can use that point. That will be a defined point. So when I graph the first one, 4, 2, you'll have a closed circle, and then 6, 3, and then 8, 4, and then 10, 5. the rest of the function will go that way. Crazy, right? All right, all good on that one?
Yes, sir.
Yeah. Perfect. Which means we have one more to graph. Actually, probably two, but not bad. Okay. Let's go ahead and graph this piecewise function, and we're going to do it the same exact way. We're going to start with the function negative 2x plus 5, and my xy chart x and y equals negative 2x plus 5. And we can only use this if my values are less than or equal to 1. So again, it tells us where to start. We're going to start at 1 and go less than 1. So 0, -1, -2, -3. That's probably good enough. And then again, you're going to take all these x values, plug them in for x, and calculate. You're going to multiply all of them by -2 and add 5. So -2 times 1 is -2. -2 plus 5 gives me 3. 0 times -2 is 0 plus 5. So we get 5. -1 times -2 is 2. 2 plus 5 gives me 7. And now you probably see the pattern. 3, 5, 7, 9, 11. Okay. Now let's go ahead and graph. And for this one, we can use 1 because our inequality says less than or equal to. So 1, 3, and then 0, 5, and then -1, 7, -2, and 9. And we can't fit -3, 11 because of our graph. So this will come down like that. Okay. And then the last function. X and y equals x plus 2. And we can only graph this if our values are greater than 1. Okay. Well, once again, it tells you where to start. We'll start at 1 and choose values greater than 1. 2, 3, 4, 5. That's all we need. Plug them into this function and add 2. So 1 plus 2, you get 3. 2 plus 2, 4, 5, 6, 7. But this time, can we actually use the x value of 1?
Yes.
You sure?
Or no.
What does my inequality say?
Less than.
Greater than. Which means, does it say greater than or equal to?
No. So
No.
undefined.
So 1, 3 will be undefined. All right. Which means that when you graph 1 and 3, oh, look at that. You already have a point that is defined there. So here's a fun little thing that if you have a defined point and an undefined point sharing the same point, then the defined point, the closed circle, will overwrite the undefined point. So no matter what, this point will stay closed only because of that other function. And now we graph the rest of them. 2, 4, 3, 5, on and on and on. There we go. So if you have a defined point and an undefined point sharing the same point, then that point will remain closed. It will remain defined. We override it or overrule it. Okay. Any questions on graphing?
None.
None. No, not bad, right?
Easier than
The last
Tuesday.
section.
Yeah. Although this is too easy. My brain's not working.
Oh, because next week spring break.
Yeah, I didn't even realize that until you said that Tuesday.
Yeah. Nobody's realized it in any of the classes. They're like, really? Spring break's next week? I'm like, yeah. Oh, I didn't know.
I'll take
Yeah.
it. I'm not complaining, but
I'm like, well, I was like, well, truthfully, we've been on spring break since all this happened. So spring
I
break
know.
technically hasn't ended yet.
That's kind of what it felt like. That Snowmageddon.
Yeah. Well, no, remember that school went remote during spring break last year.
Oh, I see what you're saying.
So I said, we've been on the longest spring break ever still. Okay, last one. Of course, application problem. So the table below shows a recent state income tax for individuals filing a return in Kansas. If the taxable income is over $0, but not over $15, the tax due is 3.5%. If the tax is between 15 and 30,000, you'll pay 525 plus 6.25% of anything over 15,000. And if your income is over 30,000, then you'll pay $1,462.50 plus 6.5% of excess over 30,000. A, write a piecewise definition for the tax due T of X on an income of X dollars. So what that means is we're going to take this XY chart, this chart of information, and create a piecewise function out of it. So what we consider is that the over but not over are the restrictions for the piecewise function. So I'll show you how to start this off. So for A, we're going to say T of X is equal to the piecewise function of, and X represents the amount of money you make. So if you make between $0 and $15,000, you're going to get taxed 3.5% of that. So the first function we're going to have, and remember to always convert percentage to decimal, is going to be 0.035 times X. So that is 3.5% times the amount of money you make. But we can only use this function if we make between how much money?
0 and 15,000.
0 and 15,000. So there's our first restriction. So it's going to be 0 less than or equal to X less than or equal to 15,000. Okay. So there's the first one. That was easy, right? The second one, it says that if you make between 15 and 30,000, you're going to pay $525 plus 6.25% of excess over $15,000. So to make the second equation, let's go ahead and write all of this. Let's go ahead and translate English into algebra. So this is going to be $525 plus 6.25%, which again, always convert from percentage to decimal, 0.0625. And what algebraic statement could represent over $15,000? If you make over, how would you write that as an inequality?
greater than.
X greater than 15,000, right? But now we actually need to translate it into an algebraic statement, which means to make it into an algebraic statement, you just take this 15,000 and subtract it to the left. So you'll get X minus 15,000 greater than 0. So whenever you see the words over 15,000, it's going to be X minus or excess over an amount of money, X minus that amount of money. So that's what's going in these parentheses here. There we go. Okay. And now all we have to do is clean this up to put it into our piecewise function. So this is going to be 525 plus, and you have to distribute these two. You'll get 0.0625x minus whatever 0.0625 is times 15,000. $937.50. And now combine these two and you'll get 0.0625x. And what's that? Minus 525. Oops. Minus 412.5. Okay. So that's the equation. That's going to be the second equation that represents the second line for taxable income. So right here, we're going to put 0.0625x minus 412.5. But we can only use this equation if you make between how much money?
Between 15 and 30.
There you go. Whew. All right. So that equation would represent anybody in the 15 to 30,000 tax bracket. Okay. And now for the third one, if you make over $30,000, you are going to pay $1,462.50 plus 6.5% of excess over 30,000. So once again, take that statement and translate it into algebra. So we're going to have 1462.50 plus, change the rate to 0.0645. And how would I represent excess over 30,000? What would I write? X minus what?
30,000.
There you go. And there it is. Just clean it up. Distribute those two. Okay, so distribute those two. (0.0645x minus whatever 0.0645 times 30,000 is, which is 1935. Combine these two. And we'll get 0.0645x minus 472.5. That'll go right here. 0.0645x minus 472.5. And this equation only works if you make over how much money?
30,000.
30,000. And there you go. There's the answer for A. Not too crazy, right? Okay. B says determine the graph of T of X. All right. So let's go ahead and Desmos this bad boy. So B just wants us to graph it, which means if I graph this, since it deals with money, it's only going to be in the first quadrant. So let's go ahead and use Desmos for this. Oops, don't need to do that. You go there, you go here. Gonna save us some time. All right, so go back here, and I'm gonna type in our functions, line for line, 0.035 x, and then I'm gonna put the restriction that we are between 0 less than or equal to x less than or equal to 15,000. I think on my MATLAB, it's just going to make you choose a function that looks just like it. So here, let me make my graph appropriate. I'm going to say that we're going to start at 0 and end at 30,000. There we go. Good. What should I make my y values? We're going to make that 0, and let's say 2,000. Is that going to work out for us? Yes. Okay. So there we go. There's the first piece of our graph. It's going up and to the right. Now I'm going to type in the red function. 0.0625 x minus 412.5. And the restriction for that one is from 15,000 less than x less than or equal to 30,000. All right, good. And there it is. There's the purple line. Or for us, it's our red line. So that's going to look just like that. And then the very last one is 0.0645 x minus 472.5. And that restriction is going to be anything over 30,000. Okay. There we go. Why did it look like that? X greater than 30,000. Oh, I get it. Okay. So starting there. Okay. So that means the next one, my green line is going to look, actually that should have been blue, right? I switched the colors up. So it's just going to go off to the right like that. So down here should be blue. So we're going to get something similar like that. Thanks, Desmos. Okay. Did I miss a 0? Let me see. I did miss a 0. That's why. Okay, there we go. That's better. So maybe not so straight edge, but that's what our graph is going to look like. Okay. Maybe I can fix it here. So we'll start off. Blue, and then red, slight increase, and then green just increases a little more. There we go. Okay, graphed by Desmos, of course. Okay. And then the very last question, C. C says, find the tax due on a taxable income of 35,000. So this says take 35,000 and plug it in for X. Well, look at our restrictions. What restriction does 35,000 fit on? First, second, or third?
Third.
Third. So that means we're going to plug it into 0.0645 times 35,000 minus 472.5. And we're going to get the taxable income, or the taxes owed on people who make over $30,000. And that's going to be $1,785 in taxes. There you go. And that's it. That was 2.2.
Easy enough.